Mars moon Phobos, and the case for the mission to this enigmatic moon. Remember that Buzz Aldrin told us that people should be asking, who put the monolith on the Mars moon Phobos? There's a huge monolith there. Now I'd like to refer to the Emerald Tablets supposedly written by Thoth the Atlantean, who was one of the first rulers of Egypt. He credited himself with building the Giza plateau, pyramids, and Sphinx, and he says he has his spaceship buried under one of the Sphinx in the plateau of Giza. Now, the monolith here, referred to by Buzz Aldrin, we shouldn't be surprised, perhaps because of the fact that in the Emerald Tablets, Thoth says that one of the generals that was exiled from the Atlantean community on Earth was exiled to Mars, and along with his generals, and buried there eventually under a face on Mars, and that his generals were buried under pyramids on Mars. So there's a lot of questions that have to be answered concerning Mars. Of course, that was when Mars had an Earth-like atmosphere. Now, ask any space enthusiast, and almost anyone will say humankind's ultimate destination is Mars, but NASA is currently gearing up to go to an asteroid. The space agency says this asteroid initiative will help in the eventual goal of putting people on Mars. And what if instead of going to an asteroid, you went to Mars or the moon Phobos? 3 prominent planetary scientists joined forces in a new paper in the journal Planetary and Space Science to explain the case for a mission to Mars, the moons of Mars, particularly Phobos. The moons are Phobos and Deimos. Phobos occupies a unique position physically, scientifically, and programmatically on the road to exploration of the solar system, the scientist says. In addition, the moons may possibly be a source for in situ resources that could support future human exploration in circum-Mars space or on the Martian surface, but a sample return mission first could provide details on the moon's origins and makeup. The Martian moons are riddles wrapped in a mystery inside an enigma. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. Phobos and his sibling Deimos seem like just 2 asteroids which were captured by the planet Mars, and they remain the last objects of the inner solar system not yet studied with a dedicated mission. But should the moons be explored with flybys or sample return? Should we consider boots or bots? The publications and mission concepts for Phobos and Deimos are numerous and go back decades. The authors of The Value of Phobos Sample Return, Murchie, Britt, and Peters, explore the full breadth of questions of why and how to explore Phobos and Deimos. Dr. Murchie is the principal investigator of the Mars Reconnaissance Orbiter's CRISM instrument, a visible infrared imaging spectrometer. He's a planetary scientist from Johns Hopkins Applied Physics Lab, APL, which has been at the forefront of efforts to develop a Phobos mission. Likewise, authors Dr. Britt from the University of Central Florida and Dr. Peters from Brown University have partnered with APL and JPL in Phobos-Deimos mission proposals. APL scientists are not the only ones interested in Phobos or Deimos. The Jet Propulsion Laboratory, Ames Research Center, and the SETI Institute, that search for extraterrestrial extraterrestrial life, that is, SETI Institute, have also proposed several missions to the small moons. Every NASA center has been involved at some level. But the only mission to actually get off the ground is the Russian space agency's Phobos Grunt, GRUNT. The Russian mission was launched November 9, 2011, and 2 months later took a bath in the Pacific Ocean. The propulsion system failed to execute the burns necessary to escape the Earth's gravity, and instead its orbit decayed despite weeks of attempts to activate the spacecraft, but that's a whole other story. The value of the Phobos sample return first discusses the origins of the moons of Mars. There is no certainty. There is a strong consensus that Earth's moon was born from a collision of a Mars-sized object and Earth not long after Earth's formation. And just as this is just one possibility for the Martian moons, Murchie explains that the impacts that created the large basins and craters on the moon could have spawned Phobos and Deimos, ejecta that achieved orbit, forming a ring and then coalesced into the small bodies. Alternative theories claim that the moons were captured by Mars from either the inner or outer solar system, or they could have co-accreted with Mars from the solar nebula. Murchie and co-authors describe the difficulties and implications of each scenario. For example, if captured by Mars, then it's difficult to explain how their orbits came to the near circular and near equatorial with synchronous rotational periods. And we have a very beautiful image of Phobos, the MRO high-rise image of the Martian moon taken on March 23rd, 2008. You can see pockmarked craters and also a very big indentation on one of the sides and very enigmatic scratches on the surface, parallel scratches to each other. Very strange. To answer the question of origins, the paper turns to the question of their nature. Murchie explains that the limited compositional knowledge leaves several possibilities for their origins. They seem like D-type asteroids of the outer system belt, the outer asteroid belt. However, the moons of Mars are very dry, void of water, at least on their surfaces as the paper discusses in detail. The flybys of Phobos and Deimos by NASA and ESA spacecraft is simply insufficient for drawing any clear picture of their composition or structure, let alone their origins, Murchie and co-authors explain. If the moons were captured, then they have compositions different from Mars. However, if they accreted with or from Mars, then they share similar compositions with the early Mars when forming or from Martian crustal material, respectively. The paper describes in some detail the problem that billions of years of Martian dust accumulation presents. Every time Mars has been hit by a large asteroid, a cloud of debris is launched into space. Some falls back to the planet, but much ends up in the orbit. Each time some of the debris collided with Phobos and Deimos, Murchie used the term witness plate to describe what the two moons are to Mars. There is an accumulation of Martian material and also material from the impactors covering the surfaces of the moons. Flyby images of Phobos show a reddish surface similar to Mars and numerous tracks along the surface as if passing objects struck, plowed, or rolled along. However, the reddish hue could be weathering from solar flux over billions of years. The paper continues with questions of the composition and how rendezvous missions could go further to understanding the moon's makeup and origins. However, it's the sample return that would deliver the pay dirt. Despite how well NASA and ESA engineers have worked to shrink and lighten the instruments that fly, orbit, and land on Mars, returning a sample of Phobos to labs on Earth would permit far more detailed analysis, of course. Science fiction writers and mission designers have imagined Phobos in particular as a starting point for the human exploration and colonization of Mars. A notable contemporary work is Red Mars by Kim Stanley Robinson. However, the storyline is dated due to the retirement of Space Shuttle and the external tanks Robinson clustered to form the colonization vessel. While the paper by Murchie et al. Is purely scientific, fiction writers have used the understanding that Phobos is far easier to reach from Earth than the surface of Mars. And we will see the delta V chart showing the stair-step method of how to get there. And this is the stair-step method, Moon, Mars, Earth, delta Vs. Now, Phobos orbiting at 9,400 kilometers, that's 5,840 miles, and Deimos at 23,500 kilometers, 14,600 miles above Mars, avoids the need for a 7-odd minutes of EDL terror, entry that is, descent and landing, and pulling oneself out of the Martian gravity well to return to Earth. Furthermore, there is the interest in using Phobos as a material resource, such as water, material for rocket fuel, or building materials. The value of a Phobos sample return discusses the potential of Phobos as a resource for space travelers in C2 resource utilization, ISRU for short, in the context of its composition, how the solar flux may have purged the moons of water, or how Martian impact debris covers materials of greater interest and value to explorers. Now, the thing is, though, these things don't have atmosphere, so this would be detrimental travel for humans. Perhaps it should be done by robots. Anyway, even they would be susceptible to cosmic and solar radiation. But anyway, going back to this, with so many questions and interests, what missions have been proposed and explored? The Murchie paper describes a half dozen missions, but there are several others that have been conceived and proposed to some level over several decades. At present, there is at least one mission actively pursuing funds. The SETI and Ames proposed Phobos and Deimos and Mars Environment, PADME for short, PADME. The mission led by Dr. Pascal Lee is competing for discovery program funding. Such projects must limit cost to only $425 million or less. You can understand, is that enough money? That or less, and be capable of launching in less than 3 years. They are proposing a launch date on the SpaceX Falcon 9. The PADME mission design would reuse Ames LADI hardware and expertise. However, it does not go so far as what Murchie and co-authors argue, returning a sample from Phobos. PADME would maintain a synchronized orbit with Phobos and then Deimos for repeated flybys. The mission is likely to cost in the range of $300 million. Stardust, a relevant mission due to its sample return capsule, launched in 1999 and had costs which likely reached a similar level by the end of the mission in 2012. The Russian Space Agency is attempting to gain funding for Phobos Grunt 2, but possible launch dates continue to be moved back to 2022 and now possibly 2024. Additionally, each of this paper's authors have missions proposed described by Dr. Peters, JPL, Lockheed Martin, proposed by Aladdin Mission, and Dr. Britt at APL, also with Lockheed Martin, proposed the mission Gulliver. Both would reuse the Stardust sample return capsule, and Dr. Murchie also describes his APL-JPL mission concept called Merlin, Mars Moon Exploration, Reconnaissance, and Landed Investigation, Merlin for short. Phobos and Deimos are the last two of what one would call major objects in the inner solar system that have not had dedicated missions of exploration. Several bodies of the asteroid belt have been targeted with flybys, and Dawn is nearing its second target, the largest of the asteroids, Ceres. So sooner rather than later, a spacecraft from some nation, not necessarily the United States, will target the moons of Mars. Targeting Phobos and Deimos missions are also likely to include both flyby missions and one or more sample return missions. A U.S.-led mission with a sample return in the Discovery program will be strained to meet both the budget criteria of $425 million cost cap and the 3-year development period. Those utilizing the Lockheed Martin LM Stardust design have a proven return capsule and spacecraft buses, structure, mechanisms, and avionics for reuse for cost and time savings. This includes 5 generations of the LM flight software that holds an incredible legacy of missions successes, starting with Mars Odyssey, Genesis, Spritzer, and now even Maven. All 3 proposals by this paper's authors could be revamped and proposed again and compete against each other. All 3 could use Lockheed Martin past designs. Cooperation in writing this paper may be an indicator that they will join forces, combine concepts, and share investigator positions on a single NASA-led project. The struggle for federal dollars remains a tough, tight battle, and with the human spacecraft program struggling to gain a new footing after Space Shuttle, dollars for interplanetary missions are likely to remain very competitive. However, it appears a Phobos Deimos mission is likely within the next 10 years. This is by Universe Today, Tim Ryers on phys.org. Please leave your comments. Thank you for your support.